In the previous lectures, we talked about double angle formulas. Now we're going to take a look at half angle formulas. We learned that cosine of 2x was cosine square x minus sine squared x. But there were two other versions of this. One of them was cosine of 2x was 2 cosine square x minus 1, and the other one was cosine of 2x equal to 1 minus 2 sine the square x. If we take these two versions and solve for cosine squared, so if I take the first one and solve for cosine squared x, I will get 1 plus cosine 2x divided by 2. And similarly, on the second one, if I solve for sine squared x, I will get 1 minus cosine of 2x divided by 2. Now let's replace x with x over 2. So if we do that, then cosine squared of x over 2 will be 1 plus cosine 2 times x over 2, the whole thing divided by 2, which we can simplify this to 1 plus cosine x divided by 2. And I'm going to do the same thing for sine squared. So sine squared of x over 2 will be 1 minus cosine of 2 times x over 2, the whole thing divided by 2. Simplify this one is 1 minus cosine of x divided by 2. Now, so far, we know the formula for sine squared of x over 2 and cosine squared of x over 2. Now, for tangent squared of x over 2, we know that tangent is sine over cosine, but I have tangent squared, so that will be sine squared and cosine squared, and our angle will be x over 2. We're going to put the equivalent formula for sine squared and cosine squared. So this is 1 plus cosine x divided by 2. No, actually this will be 1 minus cosine x divided by 2, and the denominator will be 1 plus cosine of x divided by 2. Simplify this, we get 1 minus cosine x over 1 plus cosine x. So these formulas we just found are called half-angle formulas. But keep in mind that they are for cosine squared, sine squared, and tangent squared. So you need to be aware that these are for squared, not just cosine of x over 2. So let's do a couple of examples and see how we're going to use this. I want to find exact value of sine of pi over 8. Now pi over 8 is the same as pi over 4 divided by 2. So sine of pi over 8 will be the same as sine of pi over 4 divided by 2. So I'm going to let x be equal to pi over 4 and use the formula that we just found. So this would be 1 minus cosine of pi over 4 divided by 2. Now cosine of pi over 4 is radical 2 over 2. So now I'm going to multiply by LCD 2. So my final answer is 2 minus radical 2 over 4. But now this answer, it's not really for sine of pi over 8. It's actually for sine squared of pi over 8. So we need to find sine of pi over 8. So sine of pi over 8 will be a square root of sine squared of pi over 8. So we're going to take a square root of 2 minus radical 2 divided by 4. And this becomes a square root of 2 minus radical 2 divided by radical 4. And this will be square root of 2 minus radical 2 divided by 2. So I intentionally left this square out because it's very easy trap to fall into. We were looking for sine of pi over 8, and we have the formula for sine squared of pi over 8. We do the calculation, but then at the end we need to take square root of it. Now let's look at another example. We are given tangent of x to be equal to 2 and x to be between pi and 3 pi over 2. But we want to find tangent of x over 2. So tangent square of x over 2 is 1 minus cosine of x divided by 1 plus cosine of x. So from the given information, I need to figure out what is cosine of x. X is given to be between pi and 3 pi over 2. So our angle is in third quadrant. In the third quadrant, cosine will be negative. So I'm going to draw my reference right triangle. And let's say this is angle X. Tangent, it's opposite over adjacent. So that would be 2 over 1. And this is my 90-degree angle using the Pythagorean theorem. The hypotenuse will be radical 5. So now cosine of X will be 1 over radical 5. But in the third quadrant, cosine is negative. So tangent square of X over 2 then will be 1 minus negative 1 over radical 5 over 1 plus negative 1 over radical 5. We're going to simplify this. This becomes radical 5 plus 1 divided by radical 5 minus 1. Now, this is the answer for tangent square of X over 2. I'm going to rationalize the denominator by multiplying the top and bottom by the conjugate of the denominator, which is radical 5 plus 1. The numerator, there is no need to FOIL it out. This is simply radical 5 plus 1 quantity square, but the denominator becomes radical 5 squared minus 1 squared, which is basically the difference of two squares. So keep the numerator the way it is, simplify the denominator, and that becomes 5 minus 1, which is equal to 4. Now this is the answer for tangent square of X over 2. So tangent of X over 2 will be plus or minus the square root of that expression. Radical 5 plus 1 quantity square divided by 4, which we're going to get plus or minus radical 5 plus 1 divided by 2. So the question now is, are we going to go with a positive answer or a negative answer? So recall that X was between pi and 3 pi over 2. If we divide by 2, we're going to get pi over 2, we're going to get X over 2, and we're going to get 3 pi over 4. So that concludes that X over 2 is in the second quadrant. And in the second quadrant, tangent is negative. So our final answer is tangent of X over 2 is equal to negative, and then radical 5 plus 1 divided by 2. Let's look at another example. we can show that sine of 7 pi over 12 is equal to radical 2 plus radical 6 divided by 4. Also, we can show that sine of 7 pi over 12 is 1/2 times the square root of 2 plus radical 3. So we want to show these two answers are equal. So I'm going to start with the first one and square it. But before I square it, let's see if we can simplify a few things. Radical 2 and radical 6, if I rewrite radical 6 as radical 2 times radical 6, then we can factor radical 2. I just made a mistake. I got to redo this part. So I could have written radical 6 as radical 2 times radical 3. I'm still going to square the whole thing. When I square this radical 2, I get 2. When I square 4, I get 16. But when I square this expression, I'm just going to keep it the way it is. Simplify 2 and 16, we get 1 over 8. Now, if I go ahead and square the inside using some of the formulas that we learned from algebra, this will be 1 plus 2 radical 3, and then at the end you have to take the radical 3 and square it, and you get 3. Simplify the inside, this will be 4 plus 2 radical 3. Factor 2, this will be 2 plus radical 3, and this is over 8. Now reduce this answer, we get 2 plus radical 3 divided by 4. Now keep in mind, this is that expression squared. So now let me move over here, and we're going to take a square root of radical 2 plus radical 6 over 4 quantity squared, which is taking the square root of 2 plus radical 3 over 4. The numerator I cannot simplify, so that would be a square root of 2 plus radical 3 divided by radical 4, which we're going to get radical 2 plus radical 3 all over 2. And this is the expression that we wanted to show that was the other form. I hope this lecture helps you understand the half angle formulas and how to play with them.